Let's move into section 10.2. We're going to work on 3 by 3 systems of equations. So the geometry is kind of stepped up a little bit. Instead of having just a line, an equation like this, 2x plus y plus 4z equals 12, is no longer a line, it's a plane. It's the entire plane. So instead of looking for where two lines cross each other, we're trying to look for two planes, or three planes intersect at a point. Now see if you can use the walls, the floor, and the ceiling of the room to try and figure out where three planes can intersect at one point. Where would it be? The corner. Yeah, the corner points. So front wall, side wall, ceiling, all meet at a corner. And that's what we're looking for. We're trying to find a solution to a system of linear equations, a 3 by 3 system of linear equations. Now the geometry gets a little more complicated. You could have an infinite number of solutions if you have three planes that meet along a line. You could have no solution if the three planes don't have a common point. But there's a lot of different ways that this could happen. You could have parallel planes, two planes that are the same and one that's parallel. The geometry gets pretty complicated. But the good news is we don't have to worry about it. What we have to worry about is trying to solve it if it has a solution and parameterize it when it doesn't. If it has an infinite number of solutions, I should say. So let's start out with this 3 by 3 system of equations right here. The first thing that you're going to do in solving this 3 by 3 system of equations is eliminate two of the variables from, or one of the variables from two of the equations. So I'm going to choose the first equation and eliminate the y's from the second two equations. Now let's just take a look at equations 1 and 2. What would I have to multiply this by and add it to this row to get rid of the y here? Negative 2. So let's do that. Negative 2 times row 1 added to row 2. So there'd be negative 4x minus 2y minus 8z equals negative 24. And I'll add that to x plus 2y plus 2z equals 9. And when I add those two together, I get negative 3x minus 6z equals negative 15. And that's exactly what I have right there. We're going to use the same row and get rid of the y's from the third row here. So what would I do to get rid of the y down here using that first row? Multiply by 3. Thank you. So 3 times row 1 added to row 3 is going to look like this. I'll get 6x plus 3y plus 12z equals 36, added to 3x minus 3y minus 2z equals 1, for a total of 9x minus, plus 10z equals 37. So that's what I have right here. So your first step is to eliminate a single variable from two of the equations. Now why is that? Well, if you look at what we have, just those two, you have two equations and two unknowns. So, okay, two equations and two unknowns. We can deal with that. One way to do it is substitution. Another way to do it is the addition method. Here, let's choose the addition method. If I multiply the top equation by, say, 3 and add these two equations together, what do I get here? Negative 8z equals negative 8. So z equals 1. Now if z equals 1, we still need to figure out what x is. So how are you going to figure out what x is? Can I plug it into one of these?
It'd be easier to just do it
Yeah, let's do it with these two down here. Just stick with these two. So we'll plug in z equals 1 here. So negative 3 times x minus 6 times 1 equals negative 15. Negative 3x minus 6 equals negative 15. Add 6 to both sides, and I get x equals 3. Great. 2 down and 1 to go. I need to figure out what y is. Now I can't plug it in anywhere here because I don't have a y. Yeah, let's go to one at the top. Say, well, for lack of a better one, this one. And plug in 3 for x and 1 for z. 6 plus y plus 4 equals 12. Very good, thank you. Y equals 2. The way you find your answer written in the back of the book is like this. X, Y, and Z. Kind of like our ordered pairs. They're also going to be in alphabetical order. There's a lot of different names for stuff like these. Ordered triplets. Three-tuple is kind of one of my favorites when I call it a three-tuple. I don't know. It's just, I don't know where these things come from. But in any case, your answer should be X, Y, and Z. Now, if you wanted to check this, and these problems are starting to get a little bit longer. They're worth a few more points. If you wanted to check your answer to make sure you got it right, how could you do it? Yeah, plug it back in. What if it worked in the first two equations but not in the third one? Yeah, then it's wrong. It has to work in all three equations, but it should. All right, so let's practice a couple more of these. The general workflow is this. You're going to pick a equation and use it to eliminate a variable from the other two. Once you've done that, once you have two equations and two unknowns, solve those any way you like. You can solve it by graphing, substitution, addition. You can use the intersect on your calculator. That's fine, whatever works. After you have those two numbers, then go back to one of your original equations and find the third one. But that's it. That's your general workflow in a nutshell. Let's do a couple more like this. We'll start with problem number 24. X minus y plus 2z equals 2. 3x plus y plus 5z equals 8. And finally, 2x minus y minus 2z is negative 7. Now you're free to choose any variable from any equation to help eliminate from the other ones. But to make it easy on yourself, I'd suggest you choose something with a coefficient of 1 or negative 1 as the variable and equation you want to work with. So, what's that? The y's cancel. So using the y here wouldn't be a bad idea. Or the y here, or the x here. So in my mind, there's 4 good choices. I'll let you pick. What variable and what equation do you want to use?
Cancel the y's.
Get rid of the y's?
Yeah,
Using the top equation, the middle equation, or the bottom equation?
top.
Top. All right. So that's going to make it nice and easy. So let's take a look here. We'll take row 1 and simply add it to row 2. Right? Because negative y and y are going to cancel each other out. So that'll give me x minus y plus 2z equals 2. Added to 3x plus y plus 5z is 8. When I add those, I get 4x plus 7z is 10. So 1 down. Now just leave that there. We need to repeat that process to get rid of the y from this bottom row. How am I going to get rid of the y in the bottom row? I can't add these anymore, right? Because that would give me negative 2y. So what do I have to do? Multiply by negative 1. So negative 1 times row 1 plus row 2 is going to be negative x plus y minus 2z equals negative 2. Added to 2x minus y minus 2z equals negative 7. So x minus 4z equals negative 9. And that's perfect. That gives me 2 equations and 2 unknowns. 4x plus 7z equals 10, and x minus 4z equals negative 9. You're free to solve these any way you want. Graphing, substitution, addition. Later on, we'll learn Cramer's rule, inverse matrices. There's no shortage of ways you can solve this, but let's keep it simple. For me, I don't know, 2 things look pretty easy. One would be substitution method. Let's rewrite this as x equals 4z minus 9. Just moving the 4z term to the right-hand side. And then I'll substitute that into the top equation. That'd be 4 times 4z minus 9 plus 7z equals 10. 16z minus 36 plus 7z combine like terms. Let's see. 23z minus 36 equals 10. And I think z is going to be 2. Yay. Okay. Z equals 2. Well, we need to know what x is then. If z is 2, let's plug that back in here. X equals 4 times 2 minus 9. So x would be negative 1. Two down. 1 to go. Now, if one of these equations looks easier than the other, use that one. I think the first one looks pretty nice, so we'll do that. Let's plug that back into x minus y plus 2z equals 2 and get negative 1 minus y plus 2 times 2 equals 2. So it's negative y plus 3 equals 2. Negative y equals negative 1, so y equals 1. Overall, your answer would be negative 1, 1, and 2. Nice. Now, I'm going to give you a chance to do one of these on your own. Before I do, though, and I'm kind of hoping these are review, but before I do, is there some questions or thoughts that you might have on problem 24? So it's going to be your chance to decide how well you know this stuff. Let me give you one little tip here, and it's not going to help you on the test, but it is going to help you at home. If you're trying to study this stuff at home, you're like, gee, I just don't know. Or I keep on getting these wrong. I don't know where my mistake is. Well, if you're studying this at home and you look up the answer in the back of the book and you see it's this, x, y, and z, what you should do is look back at this set of equations. Thank you. look back at this set of equations. Does this work in this set of equations? Well, 4 times negative 1 is negative 4 plus 14. Yeah, that's 10, so that works. So basically, by checking this in this intermediate step, you're finding out, did I make a mistake getting here, or was my mistake after here? But it narrows down where you have to look in terms of finding out your mistake. It's what I do when I grade your papers, is I look back at this intermediate step. I'd like to see that very clearly. For your problem, try problem number 26. 2x plus y minus z equals negative 8. Negative x plus y plus z equals 3. And negative 2x plus 4z equals 18. Now this one's actually kind of nice. Can anyone figure out what's nice about this? Y is already gone from the last one. So that means if you pick one of these equations and eliminate y from one of these other two equations, then you can finish solving, because you'll have this equation missing a y and another equation missing a y. For consistency, let's use this equation to get rid of the y from this equation. So use row 2 to get rid of the y from row 1. So I'm going to walk around and try and help out here a little bit. But here you really want to make sure that you know this stuff. You got a test on Tuesday. All right. So I put the little timeouts there so that if you're watching a video, you can kind of fast forward. Well, you can use anything you want. I think to me, the easiest thing would be multiply the bottom row by 2. Sure.
We're gonna try to eliminate y because the other equation y is missing. We want to keep that. We want to keep that equation. Go back to equation number 2. In order to eliminate the y, times the equation y equation 2y negative 1.
So I'm using these two.
You want to keep the third one.
Which rows am I using? One and
One and first and second. But you need to times the second one by negative 1 first. So you're using the first two, right? So I'm gonna say row 1
I thought he took that out.
plus
6? No. There's an A and B?
Oh, it's minus.
No, wait.
Yeah, no, it's a minus.
You're really close. I mean, I can't spot it right off the top of my head.
Then what did I do wrong?
Oh, because I did that, exchange to that.
I got
Good fractions? It's funny, because this is really taking us like somewhere along there.
Negative z, negative z,
What are your stats?
2z.
so I started off, I solved,
So you eliminated the y from
I just
that equation.
started losing a bunch of space. That's how I went
Down.
down.
This one.
This is 26.
So those two equations.
Yes.
This one.
So
Those are your start equations. You're gonna
I
solve
started
those
off
simultaneously.
here and I solved for y.
You mean eliminate y.
Yeah. So I solved this for.
Okay, so let's take a look here. We've already gotten rid of the y from this equation. So we've got a negative 2x plus 4z equals 18. If I get rid of y from another equation, then I'll be in good shape. I can just solve the 2-by-2 equations that I get when I put them together. So if I multiply negative 1 times row 2 and add it to row 1, I get x minus y minus z equals negative 3. Added to 2x plus y minus z equals negative 8. That gives me a total of 3x minus 2z equals negative 11. So let's put those two together. 3x minus 2z equals negative 11. And now we can solve this any way you'd like. You can solve it by the addition method, by substitution, by graphing, although, you know, probably more of a pain to do it by graphing or something like that. So the easiest thing that I see is to multiply the bottom equation by 2. And when I do that, I end up with negative 2x plus 4z equals 18. I'm going to add that to 6x minus 4z equals negative 22, for a total of 4x equals negative 4, and x is negative 1. Yay! 1 down, 2 to go. If x is negative 1, let's put that back into the original equation. Negative 2 times negative 1 plus 4z equals 18. So subtract 2 from both sides. I get 4z equals 16, so z equals 4. 2 down, 1 to go. With both x and z, I need to come back up here and plug in an equation, find y. Does it matter which one of these I use? Not so much. You just can't use the last one. It's not going to give you any information. But let's just use the first one. So that's 2x plus y minus z equals negative 8. 2 times negative 1 plus y minus 4 equals negative 8. So that's going to be negative 2 and negative 4 give me negative 6. Adding 6 to both sides, I get y as negative 2. Overall, negative 1, negative 2, and 4. Whew. All right. Let's take a break here, and we'll finish up in a little bit.